Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll implement a brand new save load system for the game, and alongside it, a seed-based random number generator. Let me show you how it works. So I started a new run here, and the map looks like this. When you start a new run, that run is automatically saved. So if I press escape now, we have the new pause menu, where we can go back to the game, or alternatively, we can quit to the main menu. And in the main menu, we have a continue button. And if I click on this, you can see that I'm greeted with the same map again. So if I go into this battle, I encounter two bad enemies. Both of them are intending to attack me. I drew these cards and my draw pile looks like this, right? So if I press escape again, go back to the main menu, the game is automatically saved at the start of each room as well. So if I click on continue, the same thing happens. Two bad enemies, both of those are intending to attack me. My draw pile looks the same, and I can start playing this battle however I want to. And after I kill those bad enemies, I have the rewards, which are also set in stone. So I have 57 gold, I can add a new card, and all of those cards are AoE attacks. Pretty cool. So if we skip this reward and continue, the next one will be a shop, a fight, or another fight. So the game is automatically saved when you exit a room as well. So when you go back to the map, the game is saved. So if I press escape now, go to the main menu, press continue, I do have the same amount of health, the same amount of gold, and these 3 rooms to choose from. So if I go to the shop, again, the game will be saved when I go inside the shop. So I have the same cards and the same relics for the same price. If I were to, again, press escape, go back to the main menu, press continue, you can see that the numbers are the same. I still can't afford any of them, and the items themselves are the same too. So I can click on continue as many times as I want. I won't get any other deals. And if I leave the shop, I can only pick this battle. I go back to the main menu, press continue, same thing, right? So everything is saved until the point I either lose the game by dying or winning by beating the boss. Awesome. Now let's see how we can do this. Before we jump into implementation, let's start with architecture like we usually do, right? Well, not necessarily. So for the save and load system and the RNG system, we can sort of build it out on the go, and we'll just intuitively build up and interact with the systems we need, but we still have this presentation open. Why? Well, because building a save and load system for a game is a really sensitive topic inside the game dev space. Why is that the case? Well, because most people have really strong opinions and there are a lot of different possibilities to pick from. And we'll briefly talk about 4 possible solutions inside Godot. The first one is using the config file class. The second one is using resources. The third one is using JSON files. And the last one is using binary files and or encrypted files for saving the game data. So the first version is to use config files, right? And that's a class you can use inside Godot. I pulled up the documentation for it, and this is a helper class to handle any style files. So if you don't know, any style files are just basic text files where you can store key value pairs like this. You have a key as a string, you have an equal sign, and then you have a value you want to store for that key. And this is pretty simple, right? And you can divide the whole file into different sections with this section heading like so. And for this class, you have a bunch of very easy methods to use to sort of build out this config file. So you can see the examples in the documentation. You have set value, you have a save method. You can just create a new config file like this. So it's pretty easy to use. And you have example code for loading as well. Let's see the pros and cons. So for the pros of using a config file is that it's super simple, right? You get a basic text file as a result. It's super simple. It's easy to use from the developer's perspective, and it's just a quick solution. The main downside is that you cannot store Godot objects or resources or whatever. Inside those, you have to sort of deserialize and then serialize it back when you load from the project file. Another downside of using that config file class is that you are limited to use that very simple text file format, right? And it's kind of human readable if you think about it, right? So if you care about your players being able to open that text file and edit it or hack it themselves, it's pretty simple to do. So you have to be really mindful when you pick that solution. So where can we use that config file if it's not that good for save files for multiple reasons? It doesn't mean that they are useless. I think probably the best way to utilize this class is to store project configuration or options settings for your project. Things like the current volume, the input maps, the video settings, the resolution settings. For this purpose, I think using the config file is absolutely the best and easiest way to do this. It's human readable, it's not a problem if people can tinker with it outside running the program, because these are just settings to your game, right? So if you're looking a way to save your settings inside the options menu, keep in mind that config file is a really good possibility, because that's probably the easiest way to do so. Another possible solution is to use resources, right? If you remember, we talked about how resources are stored in the file system, right? So if we store them in the file system, it's like intuitive to think that we can use them for save files as well. And it's 100% true. It's super simple. We have a resource saver and the resource loader class, respectively, which can handle saving and loading resources for us. And we already know that we can use this resource class to sort of store an array of other resources. We can nest resources inside each other. So it's pretty easy to just identify all the data we need from the game, construct a resource around it, save it to the disk and load it back, right? It's probably the easiest solution out of all of these 4 possible ones, and it's probably the most intuitive one too. So where's the but? It has to have some cons, right? Well, it's a big security risk at the moment. So Nathan from GD Quest made a really concise and well-explained video about this. I'll link that in the description of this video. But long story short, resources can execute code. And we already know that, right? Because we use this for cards, we use this for effects, we use this for statuses and so on. They all have unique code attached to them. See, that's the downside of using resources. If your players, for example, download arbitrary save files from the internet, it might be malicious. So it can have viruses or like malicious code embedded into that resource. So in a sense, it's really not that safe to use. So for your game, really consider this. If you want to have your players share save files with each other, then this is a real vulnerability you bring into your game. For this course or this tutorial, I ended up using resources, but again, please be mindful of this possibility of executing malicious code. For a game like this, we don't really care that much about save files because you just save your current run, right? So it's not that big a deal. I don't really see where players would share save files with each other. They would much rather share seeds, right? When we have seed-based random generation to check out that crazy seed you have. So in this case, I don't think it's that much of a big deal, but you really have to be mindful of that vulnerability. So we'll explain this solution out of the 4, but let's also talk about the other 2 possibilities, right? So the official docs have a dedicated page to saving games. If we take a look at the saving games documentation page, it uses a combination of groups to identify persistent objects and the use of dictionaries to save data related to all the objects. So when you save dictionaries, it's really easy to save them to a JSON file, and you have a built-in class called JSON to handle JSON files. If you never worked with JSON files, JSON stands for JavaScript Object Notation, and it's a well-established format to store and share data between different systems. So we have some example code here, and you save the whole dictionary as a JSON file, and you can read it back with this load game example they provided here. It's very clear, it's well documented, so I definitely recommend checking this out if you want to go with that solution. That said, there are some limitations of this method provided here, and they kind of go into detail what those limitations are. Namely, probably the biggest one is that this is still a human readable format, so it's easy to tinker with it, but you can't have code execution or GD script code inside that JSON. That will be invalid. So if you end up using this solution, you don't have that vulnerability you have when you use resources, because JSON files can't have arbitrary code stored inside them. The reason why I don't really like JSON, because the whole purpose of JSON files is that to have a standardized dictionary-like format to sort of pass data from one system to another. But you don't really do this if you think about it in this case, right? It's not a server-client communication or anything like that. You're still inside your game's system, And it's kind of weird to use JSON for that, but that's just my opinion. There's nothing really wrong with using JSON. I just don't think that's the intended purpose of it, but by any means, you can and should use JSON if you want to. That's the official documentation recommendation, so why not? However, you can still take this one step further. If you don't want your save files to be human readable, you can encrypt them or use something called a binary serialized file. And we have the file access class for this. It's a very easy to use and intuitive class for writing and reading files. And if we scroll down, we have a bunch of tutorials connected to it, and we have all the methods we need for this. So if we want to create a binary serialized file, it's pretty easy to do with this file access class, because basically you have to use two methods. One is called getVar, and the other one is called storeVar. So if we open up the method description, it says it stores any variant value in the file. If full objects is true, encoding objects is allowed, and can potentially include code. Internally, this uses the same encoding mechanism as the global scope var2bytes method. So what does that mean? It means that by default, you can't use store var to store full objects because it defaults to false, and that's the safe way to use it. Why? Because if you can't have full objects serialized, then this save file can't have any arbitrary and potentially malicious code inside, right? So you can just create the full dictionary like you did for the JSON version, but you can store the whole thing with this store var method and make it non-human readable, right? Because it will be encrypted with this binary serialization method. And when you read it back, you just have to open the file, and you can use the counterpart, which is getVar, and it has the same safety mechanism built inside, saying that you cannot read back full objects by default. You also have this warning message, which describes this whole scenario perfectly well. So just to quickly summarize the whole thing. If you care about your player base and want to protect them from potentially malicious code, which you should if you're making a commercial game, and you're afraid that this might happen, that players want to share save games or save files with each other, I would definitely recommend going with either the JSON format, which is described in this Saving Games documentation page, or taking it one step further, making it not easily human readable by using binary serialization, in this case with the file access class. In this course, I don't want to go into detail how all these different solutions work and don't want to implement each of them one by one. I'll just link some very good videos in the description below if you want to get more information on them. For the sake of simplicity, I'll just use the resource version for now, but please be mindful that it can contain malicious code if you want to use it in a production environment. So without further ado, let's get started. So I have my project open here, and we'll start with the save load system, then we'll move on to the seed-based random number generation. But before we can actually start working on the save load system, we have to provide a way for the player to sort of go back to the main menu from inside the game, and then when you click on continue, load back to the game state we were at. So first of all, we'll provide a way to pause the game, then from there to go back to the main menu, and then when you click on continue, we load back the last game state we were currently at. And before we implement the pause menu, let's create an input action for pausing the game. So let's go to project settings, input map, and I still have this cheat action from the last episode, but I don't really need it anymore, so we can delete this with clicking on this trash icon. Then create a new action and call this pause. Click on add or press enter. Click on the plus sign next to this new action. I just use escape, so I press escape, click on OK, and we have this new pause action inside our input map. Then we can close the project settings and start building the pause menu. The first question is, where do we create that pause menu? So I think the easiest solution is to just build it inside the run, because when we play the game, we are always inside the run scene, right? And you can pretty much pause the game from anywhere. So we'll go with that solution. And to make it a bit easier for us, I will collapse the top bar for now inside the scene tree. Click on the run, the root node. Click on the plus sign to add a new child node or press Ctrl A and search for canvas layer. We can rename this canvas layer by double clicking on it, and we can call this pause menu. And the pause menu itself will be pretty simple. So again, we'll add a new child with the pause menu selected by clicking on the plus sign or pressing Ctrl A. This time we'll search for a color rectangle. This will be the background. So let's set the anchor preset for this, clicking on this icon, set it to full rect. Then we can go into the inspector panel and change the color and change it to whatever color you like. And after changing the color, we can see that we have a bit of a problem here, right? Because the top bar is sort of in front of this pause menu. And we want the pause menu to be on top of everything else. And if you remember, we can set the property inside the canvas layer node, which is called a layer, right? The problem is it's getting kind of hard to track which layers we use, how we sort of want to order things. So let's investigate for a second. If we click on the top bar, we can see that it's on layer 3. So if we change the pause menu to layer 4, then it will be definitely on top of our top bar. But is it good if we set it on layer 4? Do we have something else on layer 4? If you think about the game for now, we do have something which renders on top of our top bar. But if you're not sure, we can always just toggle the visibility for this pause menu for now and just run the game and check, right? So if I start a new run here, I can see that the top bar is here, but if I click on the deck view, you can see that it's rendered on top of our top bar, right? The deck view is in front of our whole screen, basically. So if we close the game, toggle the visibility of the pause menu again and expand the top bar, you can see that we have our deck view here, right? So if we open this scene in the editor, we have our card pile view, and there's no canvas layer, right? So it shouldn't be a problem. It's just rendered on top of it because it's inside the top bar. Well, yes, but we do have another problem. If we press Ctrl-Shift-O and search for battle.tscn, which is one of the views available in the game, here we do have the status view layer and the card pile views on different canvas layer nodes. If we click on them, you'll see that they are both on layer 4, right? All of the other layers are lower, but these two are on layer 4. So we can conclude that we used 4 layers inside the canvas layer. So we probably want the pause menu to be on layer 5. So we make sure that it's rendered on top of everything else. If you don't want to do the calculations like this precisely, or you don't want to spend time investigating this, you can just do something like 99, which will be for sure on top of everything else, but it wasn't too hard, was it? So we can just set it on layer 5 for now. Right, what else do we need? With the pause menu selected, we can add a new child node by clicking on the plus sign or pressing Ctrl A, and we can search for a VBox container. Inside that VBox container, add a child node again. We'll add a label. With the VBox container selected again, click on the plus sign, we'll add an HBox container too. And inside that HBox container, we'll add 2 button nodes. So 1 button, and we can duplicate it with Ctrl D. Okay, so now we can set the properties for all those nodes. Select the label node first, and for the text property, we can type in something like paused. We can set the horizontal alignment to center and the vertical alignment to center as well. And I think we can make this bigger, so we can create a new label settings resource. And I kind of like that 16 pixel font by default, so it can stay like this. Then for the HBox container, let's select the first button, double click, and rename this to back to game button. And for the text property, we can just type in back. And under layout, we can set a custom minimum size of maybe 40 pixels on the X and 14 pixels on the Y. And for the second button, we can double click and rename this to save and quit button. For the text property, we can just type in MainMenu, make sure there's a space between them. And under layout, we can set the custom minimum size of this one to be something like 60 maybe. And that's a bit too wide for my liking, so I'll go with 50. Then we can do 2 or 3 more things. First of all, we'll select the VBox container and set the anchor preset to the center of the screen to make sure that it's centered. Then we can go under theme overrides and constants, and we can set a bit of a bigger separation between the elements, maybe something like 20 pixels or 15. Yeah, 15 is fine. And for the HBox container, we can set again a bigger separation under theme overrides and constants, maybe 10 pixels. Yeah, I kind of like that. So this will be our pause menu. And one final thing we need to do is to select both of these buttons. And to make it easier to hook them up in code, right click on them and access them as scene unique names. So we have this %sign appearing next to them. And I think we can create the code for the pause menu because that's all we really need. So click on the pause menu node, click on attach script, and we don't really want to use a template for this. So we can just uncheck the checkbox and rename the script to pause menu with snake case, right? Press create and see what we need to do here. The code is not that complicated, and I'll explain how pausing works in a second. So first of all, we'll provide a custom class name called PauseMenu. Then we'll define a signal here called save and quit, and we'll connect to this signal from the run, the root node itself in that code, so we can make sure that we save the game when it's needed and we can go back to the main menu when the player clicks on the main menu button. Then we have two already variable references to the two buttons we just created, and inside the ready callback, what we do is we connect to both of those buttons pressed signals with two callback methods we are yet to implement. So when we click on the back to game button, we just onPause the game. And when we click on the save and quit button, we'll call a callback method called onSave and quit button pressed. Then inside the input event callback, we'll check if the event is the pause action pressed. And if it is, we can do two things, right? If the pause menu is visible, we need to unpause the game. But if it's not, we need to pause the game. Pretty simple, right? So we have three methods we are yet to implement: the pause, the unpause, and that onSave and quit button pressed callbacks. So pausing the game pretty much means that we need to show this pause menu and set the scene tree's paused property to true. And I'll explain how it works in a second. For the unpause, we do pretty much the opposite. We hide the pause menu and set the scene tree's paused property to false. And finally, for that save and quit button pressed, we just set the pause property to false and then emit this signal, which will be handled by the run scene or the run class itself. And that's it. 6 lines of code, pretty easy. So we can save this script with Ctrl S. And if we go back to 2D view, I can explain how this scene tree's pause property works. So for all nodes or node derived other nodes inside Godot, for example, if we select the map, we have our node properties here, right? The basic ones. And under process, we have this mode property, process mode. And we can have 5 different settings for each of the nodes. The base one is set to inherit. So let's see the documentation description, which explains it better than probably I can. So the node's processing behavior. To check if the node is able to process with the current mode and scene tree.paused, you can use a method called canProcess. Okay, we don't really care about this, but what's interesting is that the scene tree.paused property influences whether a node can be processed or not. So when it's set to inherit, then the node inherits the process mode from the node's parent. And this is the default for all the newly created nodes. What does that mean? It means that when we pause the whole scene tree, all the nodes which are set to inherit will be stopped from processing. So they can't do their thing because the scene tree is paused and they inherit that property down the line. And we have a bunch of different settings which are new to Godot 4, but we really only care about 2 now. All the nodes inside the game, which shouldn't be processed when the game is paused, can remain in inherit mode. So for example, the run, if we expand the process property, you can see that indeed all of them are by default set to inherit, which is fine because if the game is paused, we don't want them to do anything. The only place where we want to do anything when the game is paused is the pause menu itself, right? So if we select the pause menu node and go to process, we can set it from inherit to always or when paused. It doesn't really make a difference here. We can just set it to always because it's probably easier. And if we save the scene, that should be it. Creating a pause menu and making the game pausable is pretty easy in Godot. The only thing we need to make sure is that this pause menu is not visible by default. Okay, so let's click on this toggle visibility eye icon because we don't want the pause menu to be visible when we start the game. So if we save this with Ctrl S and run the game, or the project, I can press escape inside our run scene and you can see that the animation stops, right? Because all the nodes which are set to inherit won't be processed by now. So if I click on back, then the game resumes and the pause menu disappears. If I press ESC, again, I pause the game and I can press ESC again. So I can either toggle the pause menu by pressing ESC repeatedly, I can use the back button, and I can also use the main menu button and the pause menu didn't disappear, but the animation starts playing because if you remember, we did two things here, right? First, we set the scene tree's pause property to false, and then we emit the signal, but we are not connected to the signal yet. So nothing happens and we are not inside the main menu, but it still does its thing because it starts animating. Awesome. So we're done with the pause menu, right? Well, yes and no. So we do have a slight problem. If you remember, we can open this deck view here, and we have two ways to close this, right? Either clicking on the back button, which works perfectly fine as is, but we can also close it with ESC. So what happens if I press escape here? Well, it didn't close the deck view. So why do you think that is? I pressed escape and it should be registered here, right? See, when we pause the scene tree, we actually pause the deck view as well, or that card pile view instance. And it's not processing, so it cannot really consume input events. The problem happens when we close this. So when I press escape again to close the pause menu, did you see that? It instantly closes the card pile view as well. Why is that? Well, to explain this, let's look at the documentation again. If you want to get more comfortable and want to know more about how input handling works in Godot, I can't recommend the documentations enough. This using input event page is absolutely brilliant in my opinion. So if you scroll down a bit here, you'll see that we have this little diagram of how processing an event inside the viewport works in Godot. What happens here? We use the input event callback, which is this one, both for the card pile view and for the pause menu. And I don't want to read through all of this right now, but one really important piece of the puzzle here is this part. So by default, events spread or propagate throughout the scene tree. And it says that the standard node input function will be called in any node that overrides it and hasn't disabled input processing with node set process input. If any function consumes the event, it can call viewport that set input as handled, and the event will not spread anymore. This is really interesting, right? Because by default, when we press escape inside the pause menu, it doesn't mean that this event is considered to be handled. It still propagates further up or down the tree. So it really depends on what you're looking for your game. In this case, I don't really like how it also closes the card pile view because you expect it to kind of only close the pause menu, right? But now that we read the docs, it's a pretty simple fix. Inside the input event callback, we can just do something like get viewport that set input is handled. It doesn't really matter if we paused or unpaused. We can just say that, okay, the input was handled and we don't want this pause action to be recognized anywhere else in the project. And if we save the script now and test the solution again by running the project, if I open my card pile view here, press escape again, you can see that it no longer closes the card pile view. Again, this might not be what you're looking for. It's a bit weird because now you actually can't close the card pile view with escape. So it really depends on what you're looking for. You can make it so when you are inside the card pile view, you cannot press escape to open the pause menu. It's highly specific to any project, how you want to handle this. For now, I'm just happy that if I press escape to close the pause menu, it doesn't close the deck view or the card pile view doesn't close. So for now, I'll just leave it as is. It's just a really interesting bit of info I wanted to show you, and I really encourage you to read the docs because they are absolutely brilliant. Okay, so that's it for the pause menu. We can actually move on to implementing the save load system now. And the first step towards the save load system is to actually hook up the pause menu inside the run so we can go back to the main menu. So let's press Ctrl-Alt-O and search for run.gd. And we'll do a bunch of new stuff here. So first of all, we'll have a new constant called MainMenu path. So we can go back to the main menu scene when we click on the main menu button from the pause menu. Then we'll also have a new onReady variable reference to our newly created pause menu. And if we scroll down in the ready callback, before we actually start creating a new run or loading a previous one, what we can do is we can connect to our pause menu save and quit signal with an anonymous function, which just gets the scene tree and changes to our main menu path, right? And that's all we really need. We can save this with Ctrl-S and we can test it just to make sure it works. If we run the project, I can press escape, click on the main menu, and I can go back to the main menu just fine. But if I click on continue, we just have this debug print message called continue run. but nothing happens, right? I can't really continue the game. And the first step towards there is to actually create a new SaveGame resource. So let's go back to 2D view. And inside our custom resources folder, we can expand it, right click on it, create new script, and we'll call this script SaveGame.gd. We can leave the template empty, but we make sure that it inherits not from the node class, but from the resource class. Click on create, scroll down, and double click on SaveGame.gd to open it up inside the editor. The script itself is pretty simple, but there are a lot of interesting little pieces of information you need to be aware of. So first of all, we'll provide a custom class name called SaveGame. Then we'll have a constant to the save file's path, which will be user://savegame.tres. So why do we need this path? First of all, I need to make sure that you understand that with this solution, you can only have one SaveGame file, which means that you can only have one run active at a time, and this will be the one which is saved. Now that I made myself clear about this, we can talk about the user path. So why don't we use the root folder we have in our file system doc, which would be res://. Well, it's pretty simple. When you export the game, the whole thing will be bundled into two files, an executable and a PCK file with all the resources, all the scripts, all the assets and everything else. And whatever you save inside the file system doc will be bundled with the game when you export it into any platform, right? And you don't want that to happen at all with the save files. You want the save file to reside somewhere else on the user's system. So if we pull up the documentation again, you can see that we have two different folders, and we have this path, which we used so far, and we have the persistent user data folder, which is this one. And it says to store persistent data files like the player's save or settings, you want to use this path instead of this one. This is because when the game is running, the project's file system will be read-only, and it's bundled up with the executable, or next to the executable, right? This path points to a different directory based on the operating system the game is running on, right? And you can also change the folder where this custom user directory lies if you want to. But we have default for different platforms, and you can sort of see this or change this in the project settings. So the key takeaway here is that you want these files to be writable, not just readable during runtime. And when you export your game, all the files inside the file system doc pretty much become read-only when the game is running. So now you know why we use this user path here. So then we have a bunch of different export variables, and these are all the data we want to save inside the save file. So first of all, we can save the run stats resource because it has information like the current amount of gold the player possesses. Then we have the character stats resource because we want to know which character the player was playing inside that run. Then we have the current deck, which is a card pile, the current health, which is an integer. We have the relics, which will be an array of relic resources. We have the whole map data, which is an array of arrays with room resources inside of those inner arrays. Then we have a last room, which was visited, which is again a room resource. We have an integer for how many floors were climbed during this run. And we'll also have a Boolean variable indicating whether the player was on the map or not when the game was last saved. Two interesting bits of information here. If we'll save this game from code, like programmatically, why do we need these to become export variables? Is a good question. The reason why is because when you save resources with resource saver inside the file system, only the export variables will be saved and serialized. The member variables won't. So if we actually want to save these values, we have to use the export variable annotation, even when we do this from code to make sure that they are saved on the disk. Another sort of advantage of this is we can emulate different save files, test data, if we just create SaveGame resources to test if the system works or not. So it's like a good side effect of having to use export annotations here. Another interesting piece of info here is that if we take a look at our character stats resource, I just press and hold Control and click on it, you'll see that the character stats resource does have a member variable called deck, which is a card pile, right? And since it extends from the stats node, it will also have a health member variable, right? So we do have all these information inside the character stats resource. We do have a health member variable and we do have a deck member variable. So if we go back to our save game, Why do we need separate export variables for both of those? I know it's a bit hard to wrap your head around this, but try to answer the question on your own. Well, the answer is pretty simple based on what I just said. We do have a deck and the current health inside the character stats resource, but those are not export variables, but member variables, remember. And if you save the character stats resource, it will be serialized in the same way the save game itself will be. So we will only save the export variables inside the character stats as well. So just by having the character stats, the current health and the deck wouldn't be saved because those are not export variables. So we can either create two new ones here, or the alternative would be to change the character stats and the stats resources and make both of those variables exported. Then we wouldn't need these two lines of code. But it doesn't really matter. I just kind of wanted to explain because it might not be that intuitive, right? Okay, so we have all the variables we need. Then we'll provide a method called SaveData, and it will be pretty simple. We just call the resource saver classes save method, and we'll save ourselves this resource to the save path we just provided as a constant. And this method returns an error code, and we'll check if that error code is okay, because if it's not, then for whatever reason we couldn't save the game and we should throw an error message. But if it was okay, that's all we need. The resource saver class will handle everything else for us. We'll also have a load data method, which will return a save game resource, and we can use the file access class to check if the file exists inside the player's machine. And if we do have a save file in the save path, we use the opposite, the resource loader's load method, load the save game from the save path, convert it to a save game resource with the as keyword and return it from the method. It's as simple as that. However, if the file doesn't exist, then we can just return null, saying that we don't have a save game yet. The question is, why is this a static function and why the save data isn't? Well, it's just to make our lives easier, because to save the data, we actually have to create a new save game resource, right? With SaveGame.new, set all the properties. So when we call the save data method, we can just say self and save that resource we just created. So it makes sense that to save the data, we have to have like a save game instance created somewhere and set those properties, right? But for loading the game, it makes no sense to create a new save game because the point of loading is that we already have one. So when we use the static keyword, remember we can just say save game as the class name .load data. So we don't have to create a new save game just to load the one we want. So it makes sense to not rely on having a save game instance when you just want to load it. And in a similar fashion, we'll have one last method called delete data. This will be static as well. And what we do is we check if the file exists inside the save path, and we'll use the directory access class, which has a method called remove absolute. And what this remove absolute does is it takes a path string as a parameter and deletes the file from the file system of the player. So why do we need to delete the player's save data at all? Well, it's because when you actually win the run or when you die, we want to delete that data to make sure that when you go back to the main menu, the continue button will be disabled and you cannot load that save file anymore, right? Because you either lost that run or you won it. So when either of those two things happen, we need to flush the save game data, so to speak. So we just delete the save game because the run ended, right? It doesn't matter why, but it did end. Okay, so the save game class itself is pretty simple, 30 lines of code. We can save this with Control S. Now we just need to use it somewhere, right? So where does it make sense to provide all this functionality? And when do we actually want to save the game? We want to save the game when a new run starts, when the player enters a new room, or when the player goes back to the map after exiting a room. And I'll explain those decisions why when we can actually test the solution. So all of these bits of information are available inside our run class. So it probably makes sense to implement this behavior inside run.gd. So let's press Ctrl+O and search for run.gd. And let's see how we can implement saving the game. The first thing we'll do is we'll provide a new member variable for the save game resource. Let's just call it save data or something like that. And it will be a save game resource. Then after our start run function, we need to provide a new one, which I just called save run, and it works like this. It takes one parameter or argument called wasOnMap, which will be a boolean. And what we do is we just grab the save data resource we currently have, and we just set all the different export variable properties we declared inside it. So we'll provide the run stats from our stats member variable. We'll provide the character stats from our character, right? We'll grab the current deck and the health from the character stats resource, the relics from the relic handler get all relics method, which we created, and we grab all the map related data as well. And when we're done with all of those export variables, we can call this save data method, which will save it inside the disk, right? So where do we call this method is the next question. Well, we said that we actually want to save the game when we start a new run, right? So if we scroll a bit up to our start run method, here we can just do something like this. So we'll say that our save data member variable will be equal to a new SaveGame resource. And then we just call this save run method we just declared or created and say that it's true that we are on a map, right? Because when we start a run, we start by looking at the map we just generated. Pretty simple, right? And for now, let's just leave it at this. We said that we want to actually save in 2 more places, right? Because we wanted to save when we go back to the map and when we enter a new room, but it would be kind of hard to test right now, so we'll just change it later when we have to. For now, we can save this and we can actually test how this works or looks like. So if we run the game now and start a new run, no error messages, which is a pretty good sign, and I can still enter inside a battle and everything works as intended. Okay, pretty cool. But what about the save game? So when we close the game and go inside project, we have this button here or this option here called open user data folder, so you don't have to look for your specific one. And when I open this folder, we do have this savegame.tres file here, which I just created, and we can take a look at this inside the text editor. So if I open it inside the text editor, we have all these pieces of text here, and you can say that, for example, the character name is warrior, which is perfectly fine because I started with the warrior. And we can maybe search for things like gold. So if I search for gold, you'll see that we have our run stats resource and the gold is equal to 70, which is fine because that's the starting gold we have declared. So we do have our save game. It's a pretty long file, but everything is there. Was on map is true. The floors climbed is equal to 0, which is fine because we just started the run. So it pretty much works. We have our save game ready to go. The next logical step would be to actually load the game, right? So provide the load functionality as well. And that's what we'll do next. And to create that load functionality, we sort of do the opposite we have in this save run method. So we again have to create a new one and we'll call this load run. And what it does is like quite the opposite. So we use the save data member variable and set it to our savegame.loadData method, loading that resource we just saw in our user folder. Again, we have an assert statement to make sure that we do have a saved data, because if it's not, then it means that we couldn't load the last save for whatever reason. But if we could, we can sort of do the opposite that we did, right? So we say that the stats should be equal to our run stats. From the save data, the character should be the character stats, the deck, the health, and so on. For the relics, we can call the relic handler's add relics method, which takes in an array of relics, which is absolutely brilliant because that's what we have inside our save file, and just add back those relics one by one. And then we sort of do the same that we did when we start a new run, and we set up the top bar and set up the event connections to make sure that the game works perfectly fine. You might see that one bit or piece of this whole thing is missing, namely anything related to the maps, but we'll get back to this in a second. That's enough to test the functionality for now, but we also need to make sure that we actually call this method, right? So if we scroll up or click on our ready callback, here we have two different run startup possibilities, right? We either start a new run, which works perfectly fine. We'll create a new instance of the picked character and call the start run method, or it can be a continued run. And all we do for now is just print a debug message, but that no longer does it. What we can do instead is just call this load run method. And that's all we need to do here. We can save this with Control S. But to actually test if it works or not, we have to open up the main menu again. Because if you remember, we just saw that when we click on the continue button, nothing happens, we just print a debug message. And that no longer does it. So let's press Ctrl+O and search for mainmenu.gd. And here we need to change a bunch of things. First of all, we'll provide a constant for our run scene to make sure that we can instantiate it when we click on the continue button and we have a run to continue. Then we also need an export variable for our run startup resource, because in the old version, we could only change this resource inside the character selector. So when we change it in the character selector, when we start a new run, we change the selected character and also set the run startups type to become a new run. But here we want to have access to that resource as well, because here we want to change it to a continued run, right? And we also have to think about whether the continue button should be enabled or disabled. So what we do inside the ready callback is we check if we load the data from the SaveGame class, it's null or not. Because if the loaded data is null, it means that we don't have a valid SaveGame right now. So the continue button should be disabled. But if we do have a valid load data, then the disabled property will be false and we can actually continue with the game. And then instead of just writing the debug print message, we do two things. We change the run startups type to be a continued run. So when we change the scene into the run scene, we know that this load run method will be called instead of starting a new one. And that's all we really need from the script's perspective. Let me just run you through it again real quick. We provided a constant reference to our run scene to make sure that we can change the scene to this when we click on the continue button. We provided this export variable dependency for our run startup, so we can change the type when we click the continue button. Then inside the ready callback, we just sort of set up the continue button's disabled property. It should be disabled when we have no valid save data and should be enabled otherwise. And when we click on the continue button, we change the run startup type to be a continued run, then change the scene to our run scene. So inside the run scene, this part of the match statement will be true, and we can start loading a run instead of starting a new one when we need to. So let's save those scripts with Ctrl S. Let's go back to 2D view, press Ctrl Shift O to quick open a scene and search for MainMenu.tscn, because let's not forget that we have an export variable which we haven't set yet. So if we select our main menu, the root node, we have this run startup slot or resource here. And if we search our file system for run startup.tres, we have one inside the run folder, right? So we can just drag and drop this over here. And you can see that by default, it's a new run with the warrior, right? But if we save this and run the current scene, the main menu scene, we do have a save file. So the continue button is enabled. And if I click on this, you'll see that something else happened, right? We do have our gold and our starting relic for the warrior. I can still click on these. I do have my deck here as well. So we can see that the loading system works. Why? Because there's no new map generated. So we can see that it's empty, and it's what we expected because we don't have the logic or the code yet to handle sort of building back the map from the save file, right? So it's empty for now. But if we close the game, run it again, and go to a new run, I can still select the characters, and if I start a new run with the warrior, I still have a map. So we sort of have this distinction now with the run startup resource that if I go to the character selector, I can start a new run, everything works perfectly fine. And now if I go back to the main menu, I can press the continue button and go back to this load state where I don't have the map yet, but otherwise it's working fine. Awesome. So we can close this for now. And one small thing we can also test is if I go to project and open user data folder again, I can delete the save file from my file system. And if I delete the file, go back to Godot and run the main menu again, the continue button will be disabled because there's no valid load file we can load right now. So that functionality works as well. I can still start a new run, go back to the main menu, and now the continue button is enabled because remember, starting a new run generates a new save game. So pretty much everything works. The next logical step would be to build the functionality to build the map back up the way it was before we save the game. So to sort of provide that functionality to load back the data from the map, we need to open up the map script and provide a way to rebuild the whole thing. Fortunately for us, the code we wrote back in the map generating episode is pretty flexible, so it will be easy to do so. Let's press Ctrl-Alt-O and search for map.gd and see what we need to change here. So we have two methods here. One is called generate new map and one is called create map, and we can sort of do our thing between those two. So we'll have a new method called load map, which takes 3 parameters. One will be the array of rooms, which we call map. One will be the floors completed or climbed, and one will be the last room which the player was in, and it will be a room resource. Then what we do is we set the map's member variables. The floors climbed will be equal to the floors completed. The map data, which we normally generate ourselves, will be equal to this array of rooms we get from the save file. And the last room will be equal to the last room we climbed according to the save file. And the cool thing about this is that we separated sort of generating the map data with the map generator and spawning the map itself into very separate parts. So if you take a look at the generate new map method, what we do is we set the floors climb to 0, then generate the map data, which is this array of rooms, with our map generator script, and then call this create map method, which will build the whole thing, right? And because we separated those two, we can just do the same. So these two methods are really similar. They are just different how we actually end up having the map data. So in this case, we load it from a file. In this case, we generate a new one ourselves. But the result will be the same. We call this create map method, which will sort of do the heavy lifting for us. One final thing we need to do after loading the map is to check whether the floors climbed is bigger than 0 or not. Why? Well, because if we save the game just after starting a new run, we need to unlock the whole first floor. But if we are already somewhere ahead the journey, we just need to unlock the next possible rooms based on the path, right? So if we are on floor 0, we unlock the first floor, the whole thing. Otherwise, we just unlock the available next rooms. And that's pretty much it. So in terms of the map.gd script, that's a pretty simple and easy to understand method, hopefully. But we do need to call this, right? So let's save this with Ctrl S. And let's press Ctrl-Alt-O and go back to our run.gd file now. So we just provided this load run method, but it's not completed yet. So if I press and hold Ctrl and click on this, you can see that here we basically do nothing connected to maps, right? So after setting up everything, we can do something like this. We call the maps load map method and we provide all the data needed from the SaveGame resource, right? Because we do have the map data, the amount of floors climbed, and the last room. So we just provide all those data so the map can generate back the whole thing. And then we have an interesting piece of code here, which is this one. So if we have a valid last room and it's true that the player wasn't on the map when the game was saved, we can just call the onMap exited with our last room. Why do we need that code? Let's think about this, and I'll come back to this when we actually test the whole thing, and I can explain my reasoning for this save load system. That's all we really need for the map to work. So if we save this and start a new run, press escape, go back to the main menu, and now if I click on continue, you can see that I get back this whole map, right? Pretty cool. So now it doesn't happen that it becomes empty. The whole map is generated back, the animations are playing, I can still interact with it, I can play the battle, everything works fine. See, the problem is if I enter the battle, I can see that this crab is attacking me for 7, and if I press escape and go back to the main menu and load the game back, I'm again greeted with the map. And that's a problem, right? Because I can do something like this. Oh, that's a crab fight. Okay, I don't want to fight the crab. I can just load back the save, check the other one. Oh, that's a bad fight. That's much better for my character. So I can basically cheat with the game and I can load back the save file and I can explore the whole map in more detail, which is not at all what we want. So since we have all the architecture already set up to handle this, it will be a pretty easy fix actually. So first of all, let's go to our show map method here. So if I click on show map, what we do is we delete the current view, show the map, unlock the next rooms. And what we also want to do is to save the run and say at this point that yes, we were on the map when this save game happened. Pretty easy, right? And the other place where we want to save the game is when you actually enter a room, right? Because if we save the game when the player clicks on a battle or clicks on a shop or a campfire, we make sure that this will be the place where the game loads back when we go back to the main menu and go back again. And this way we can eliminate this cheating we just saw, right? Because if I clicked on the battle, the game gets saved when I enter that battle, and I can no longer do this trick that I enter the battle, go back to the main menu, load back the game, and I'm still on the map. So that's not enough though, right? Because yes, we want to save when we go back from the battle to the map, but we also want to save when we go from the map to a room. So where does this happen? If we take a look at our methods we have here, we have this on map exited. It sounds like the right place, right? Because I go to a new room, and based on the room type, a bunch of things start to happen, right? I change to a campfire scene, to a treasure room, whatever. So before actually doing any of those, we can do something like this. We say that we save the run again when we exit the map and enter a new room, and set this to false, saying that, okay, we weren't on the map, or the player wasn't on the map when this save game happens. So the cool thing about this is if we go back to our load run scene now, you'll see that if we did have a valid last room and the player wasn't on the map, then we'll call this on map exited, and we'll actually go to the battle again instead of showing the map. So let's test how this works, right? Let's save this with Control S and start a new run. Okay, let's test everything. So I started a new run. We have the map here. We have 2 campfires on the side, the shop in the middle, and 4 battles, right? Press escape. Go to the main menu, press continue, it loads back, and we have the same layout. Okay. Now if I go into this battle, it should be saved again, right? So if I press escape now and go to the main menu and press continue, okay, I can no longer cheat the map, right? So let me win this battle real quick. And if I win this battle, take the gold, add a new card to my deck. Okay. I exited the battle, I entered the map again, I completed this room. So if I go back to the main menu again and load the game, I can no longer click on any of those rooms, and I can only choose from those 2, right? So I can no longer cheat like this. Perfectly fine. If I start a new battle, it's a crab again. I go back to the main menu and press continue. Okay, I can no longer cheat. So let me reason a bit why I opted for this method here. We can see that you can no longer cheat with the game. Another thing I wanted to make sure of is when you click on the battle rewards, right? You collect the gold, you may or may not add a new card to your deck. And I have 183 gold right now. So what I also wanted to make sure of is that you can't cheat by taking the gold, adding it to your gold pool, and when you save the game and load it back, you have the gold, but you can basically farm endlessly with this method. So if I click on continue now, I still have 131 gold instead, and I have to do the crab fight again. So just to make sure that we only save after we've taken all the rewards and we went back to the map. So you can't endlessly farm gold, because there was an earlier iteration of this save system which I created, and when testing I found out that, okay, so when I save the game at the end of the battle as well, I can basically endlessly farm gold, right? So this system is, or this set of rules regarding saving and loading the game is the best I can came up with, and it's pretty similar to what Slay the Spire does. So that's like a deeper explanation of the reasoning behind saving in 3 places basically. When you start a new run, when you enter a room, or when you go back to the map after exiting a room. Pretty cool, right? Awesome. So one more thing that's left to do is to actually delete the save game data when we lose, or when we go into a game over state, or when we win the whole thing. So winning the whole thing happens inside run.gd. We have this method called onBattle1, and you see now we differentiate between going to a win screen when we already beaten the boss, or showing regular battle rewards. So when we show the win screen, it means that we won the run, right? So what we can do after it is just call the save game classes delete data static function and say that, okay, now we don't need to continue this, or we cannot continue this run, so we can delete everything. That's one place. And another one is when we lose the game. So where does that happen? Well, it happens inside the battle, right? So let's press Ctrl+O, search for battle.gd, and we have this callback method called onAPlayerDied, And what we do is we request this battle over screen for the game over message. And besides that, what we can do is we can delete the save game data again, just to make sure that we cannot load this back, because what's the point, right? And that's pretty much it. If we save this with Control S, the whole save load system is in its place. Again, please keep in mind what I said in the architecture part about the different saving and loading solutions. The whole logic when we need to save and how we load is the same. You really would only need to change the save game class itself, so it wouldn't extend from the resource class, and you have to change a bunch of things regarding the implementation, but the logic, what we need to save, is the same. How and when we save it is basically the same. It's just a technical difference between the different solutions. But again, this is just a reminder that if you don't want your users to have that risk of executing malicious code with traded save files, then consider using a different solution. Okay, this is just for demonstration purposes. Okay, if you like my content, please consider checking out my Ko-fi page, where you can donate one time or become a member and get early access to all my content and videos. Before we can wrap this whole project and season up, we do have one problem which is introduced by implementing this save load system. Let me show you what I mean. If you start a new run and I go to a battle, I might say that, okay, I don't really like these cards I drew because I cannot play both of these attacks on the same turn because I only have 3 mana, right? So what I do as a smart player is press escape, go back to the main menu, and press continue to load back the whole thing. And voila, now I have a much better turn, right? Because I drew my basic attack card, so I can deal 13 damage to this crab enemy. You see the problem here? Each time I load back my save file, there is no seeded randomization, so I can do the same thing with shops. If I don't like the items or relics and cards offered inside the shop, I can just go back to the main menu, load the game back, and get a new set of relics, right? And we don't really want that, because that probably defeats the purpose of the whole game. So instead, what we want is to implement what's called seed-based random generation. And to explain how it works, we can rely on the documentation again, because it's that good. So we have a doc page called Random Number Generation, and it explains in really great detail how the whole thing works. But basically what we have is we have this randomize method, which is called once automatically, and it initializes the random number generator with a random seed. What is this seed, and how does random number generation works? So basically, computers cannot really generate true random numbers because computers operate on algorithms, right? And algorithms are by definition predictable. So we have explicit steps and operations sort of performed after one another. And so for these random numbers to appear as truly random, what they use is a seed. And it's sort of like a starting value, and all the pseudo-random numbers generated will be based on that starting value, which is called the seed. And usually, for example, in Godot, you have this method called randomize, which often uses something like the timestamp of the current system to use as a seed. So with this, each time you run the project, the timestamp will be different, so you'll get different results from the algorithm, so they appear to be truly random. And that's fine for most of the cases, and in those cases, you can use what's called global scope methods, which we used in the project. So for example, we just typed in randf range or randi range and use the arrays shuffle method, for example. And that's fine, but not in our case anymore, because we want these seeds to be stored, right, inside the save game, so we know that the random number generator will produce the same results no matter how many times I load the game or no matter what timestamp the current machine has, right? So with setting a seed specifically, you'll have much more control over what kind of numbers will be generated. Hopefully that makes sense. So we can basically use the seed to make sure that we generate the same sequence of numbers. One thing we also need to store is called the state of the random number generator, because if we set the seed, then let's say if we were to roll 6-sided dice, the first number will be 5, the second will be 2, and the third will be 1. If we don't store the state, just the seed, then we won't know how many rolls we already have with the die, right? So changing the state as well means that we know that we already rolled a 5, a 3, and a 1, and we'll roll the next one based on this sequence of events. So hopefully that makes sense. In terms of implementation, it will be pretty simple to do so. So let's hop back to the project, go back to 2D view, clear the search query inside our file system, and we can collapse all the folders basically. To make sure that we can access random number generation throughout the whole project, we'll use a global class, or an autoload as it's called in Godot. So let's open or expand our global folder here. You know, we have our sound player, the event bus here, and we'll add random number generation there as well. So let's right click on this, create a new script. We don't really need a template here. We can just rename this to rng.gd. And before we actually create the script, let's not forget to add it as an autoload to the project. So let's go to project, project settings, autoload, click on this folder icon to search for the path, go inside our global folder and double click on rng.gd. And for this one, I kind of like using all caps. So I'll just name the node as RNG with all caps and add it as an autoload. Perfect. Now we just need to write the code for this class, but it will be pretty simple, I promise. So let's double click on rng.gd and see what we need to do here. So the script will be pretty simple. First of all, we'll have a member variable called instance, which will be a random number generator. Inside the ready callback, we call this method called initialize, which we are yet to implement. What this initialize method does is it creates a new random number generator instance, set the instance member variable to reference that new random number generator we just created, and call the randomize method to set up a new seed. But we also need to have a different method when we actually want to set the instance based on saved data. In this case, what we do is we change the instance member variable to a new random number generator, but this time we don't call randomize. Instead, we set the seed property to the seed we saved inside our saved data and the state property to the state we saved inside the saved data. Then we need to have two extra methods which we used throughout the project. We have built-in methods for them, but those use the global scope random numbers, and we know that it's not really reliable on producing the same results. One of them is picking a random member inside an array, and the other one is shuffling a whole array. So these are the two methods. We sort of need to provide our own custom way of doing them because we need to make sure that we can use the seed-based predictable system when we save and load the game. So array pick random will receive an array as a parameter and return a variant. Variant is basically the class which says that, okay, this can be of any type. So what we do is we take the array and generate a random index, right? So we call the rand_i method for our instance and use the modulo operator to make sure that this random integer is between 0 and the size of the array -1. Because if I have an array of 10 elements, the indices will go from 0 to 9, right? And if I use the modulo operator with 10, then all the results will be sort of clamped between 0 and 9. Pretty straightforward stuff. And then for the array shuffle method, we will shuffle the array in place, meaning that we don't return a new array. We'll use the same one, which is passed as a parameter. If the size is less than 2, meaning we only have one element or the array is empty, we don't really have to shuffle it because we can't, right? Then we can return from the function immediately. Otherwise, we perform this operation, and the inspiration behind this way of shuffling the array is actually looking at the source code of Godot. That's the cool thing about open source, right? So what I did is I looked at the array class's source code to see how the original shuffle method works, and it's basically the same thing. So I just converted this C++ code into GD script. Let's look at how this works. So we'll provide a for loop, and it goes from the biggest index, which is the size of the array -1. Again, if we have 10 items, the last index will be 9. Goes all the way down to 0, and the step will be -1 because we decrement it by 1 with each iteration, right? And what we do is we use the instance's rand_i to get a random integer and again clamp it between 0 and i+1. So in this case, in the first iteration, this will be between 0 and 9, right? Because I will be 9, 9 plus 1 is 10, and modulo 10 will clamp the values between 0 and 9. Then we grab the array's element with that specific j index, and with the use of a temporary array, we basically swap the two elements, right? And we repeat this process until all of the elements inside the array are shuffled. Pretty cool. That's all we need from this RNG class. It's just how we use it throughout the project, which is important, right? So it's not that difficult. It's like 30 lines of code, but we need to make sure that we use this properly. So let's save this with Control S. And after saving this, let's see how we can implement it. First of all, we need to change the save game, right? Because we want to save the seed and the state of that instance of a random number generator when we have to save the game. So let's press Ctrl+O and search for SaveGame.gd. And here we'll have two export variables, two new ones. One will be called RNG seed and one will be called RNG state. And we have to save both of those when we save the game, right? So let's save this with Control S because that's all we really need from the resource itself. We just need to make sure that when we do save the game, we provide that data as well. And where do we save the game? You guessed it, we save the game in run.gd. So let's press Ctrl+O and let's go back to run.gd. And if you take a look at the list of functions we have this save run function where we provide all the data, but we are yet to provide the RNG related data, the seed and the state of the random number generator. So what we'll do here is we'll add two new lines of code and we say that the saved data's RNG seed property should be equal to the RNG Autoload's instances seed property, and the same goes for the state. And then if you think about it, we kind of have to do the same when we load the run, right? So if we scroll down a bit, we have this load run method here. And what we can do is we call this set from save data method we just created and pass the saved data's RNG seed and RNG state values to this Autoload class we have. And that's pretty much it. We have all the things set up we need for custom random number generation, but we don't actually use it anywhere in the project. So it's kind of useless as of now, but let's save all the scripts with Control S. And we need to think about where we randomly generate stuff inside the whole project. So how do we approach this? I think probably the easiest way to do it is to think about all the different cases we use random number generation, right? So for example, we know that we randomly generate the cost of cards and relics inside the shop, or that we randomly generate a battle reward gold amount between a sort of minimum and maximum value. For those, we use rand_i because we only want to generate integers, right? But if you think about enemy actions, for example, where we have weighted random distribution, there we used rand_f range because all those weights are floating point values. So we already have sort of two cases. We have rand_i for integer generation and we have rand_f or rand_f range for floating point generation. And we have two other ones which we already have our custom methods for, namely picking a random value from an array and shuffling an array in place. So these are the four instances of random things we do in this whole project, and those are the ones we need to sort of change up, right? So I think probably the easiest way to approach this at the very end of the whole thing is to use the find in whole project command. So let's press Ctrl+Shift+F to find in files, to open up the find in files window, and first of all search for rand_i, right? Click on find, and you can see that we have 8 matches in 6 files, and you can see all the places where we use this random generation. And we'll go through them one by one and decide whether we need to change it based on this RNG class or not. So let's start with the first one. It's inside battlestats.gd. Let's click on that line of code. And if we close the search results panel for now, you can see that this roll gold reward method, which we use when we win a battle, uses rand_i range. For this one, we definitely want to use the seed-based version. Otherwise, you could just replay the whole fight over and over again till you roll a bigger gold reward, right? And that's not what we want from the player. So changing this is pretty simple. Instead of rand_i range, we just say rng.instance.rand_i range, right? Because we have our own random number generator instance, which will be that seed-based version. So we can save this with Control S, go back to our search results. We have 2 matches from RNG.gd, but we don't really care about those because that's the class we just created for seed-based random generation, right? It already uses that instance, that rand_i in both places. Then the next one we have is map room. Okay, so let's click on this. What do we do here? If you remember, map room is the visual representation of a node or a room we can go to inside our map. Right? It's just setting the rotation degrees of that line 2D, which is the highlight when we click on the map icon. And I don't really care if the rotation on this will be different each time I open up the project. It's really not a big deal, I think. If you want to, you can change this to rng.instance.rand_i range, but I don't think it makes that much sense. Nobody notices that anyway. So let's go back to search results. Then we have our map generator, which is a more interesting one. So let's click on those lines of code. Inside the map generator, when we get random starting points, for example, we use rand_i_range. For the map generation, we absolutely don't care at all about this seed-based system. Why? Think about this for a second. How many times do we generate a map during the whole run? We do it once, right? So when we start a new run, we generate the whole map and then we save it once. But then whenever we save this, the whole thing will be the same. The rooms, the connections, everything. And since we only do it once, it doesn't really matter what the seed is because the seed is set before starting a new run. I don't think it makes any sense to make this seed-based, as you don't regenerate the map when you load it back, right? Because you already have all the data you need. So all the map-related things can stay actually in this global scope because it doesn't matter. You could use RNG.instance, but it makes no difference at all in this case. So I'll just leave it as is for both of those. But for the shop relic, it's absolutely important to change this because this is the place where we define the gold cost for a shop relic. So we can use rng.instance.rand_i_range for this one, save it with Ctrl S, bring back the search results and do the same for the shop card. Scroll all the way up, change this to rng.instance.rand_i_range, save this with Ctrl S. And I think that's it. So if we go back to search results and refresh it, we still have those, but we can look for rng.instance before them. So those are done. Those we don't care about. Those are in the RNG class itself. And this is done. So we're pretty much done with all the rand_i calls. You can close the panel for now and do the same for rand_f. So Ctrl+Shift+F, search for rand_f, find. And you can see that we have a couple of matches here as well. So battle stats pool is for picking the battles, right? So assigning the battles. And here, when we get a random battle for a tier, we could change it, but again, we don't have to. Think about it. When do we assign the battles to the rooms? We do this once when we generate the map, right? So we really don't have to care about seeding there because we won't call this again when we reload the game. So it's pretty much set in stone. The only reason you would do this based on the seed of the random number generator is if you had multiple acts, right? Maybe then it makes sense, but then again, if you only save the game when the act starts, it will be generated. So I don't think it makes that much sense at all to make this seed-based. Maybe if you want to make it more consistent, but I don't really see the point. So we can just leave it as is because in this demo, in this project, in this course, it only happens once when we generate the map. So this is fine. The next one we have is shaker.gd. If you remember, we use this class to sort of provide that blinking, shaking animation when a unit takes damage. And for this one, I don't really care if it's consistent or not, it's just an animation. It's barely noticeable if you change this, so I don't think it makes sense. However, for the battle reward, that's a totally different case because we use rand_f_range here inside the show card rewards method to generate the random cards we get as rewards when we win a battle. And that's definitely one where I want to keep the consistency, right? So instead of rand_f_range, we can just say rng.instance.rand_f_range and this will make it consistent. Awesome. Then we have enemy action picker.gd. And in enemy action picker, again, to get a chance-based action, we roll for a random floating point value between 0.0 and the total weight. This is good if it's consistent because otherwise I could just reload the save game until I roll for enemy actions, which are more preferred for my fight, right? So we can change this to rng.instance.rand_f_range, and this makes sure that no matter how many times I reload the fight, the enemy will do the same thing over and over again. Okay, and if we go back to search results, we have map generator. Again, map generation, really don't care about this because it only happens once. And the last one is shop.gd, where we have the blink timer for the shopkeeper, which is, if you remember, an animation to make him feel more organic. He blinks at random intervals. It's a visual thing. Again, it's up to you. To me, it really doesn't make any sense to make this seed-based, make this consistent. He can blink however he wants to, right? If we wrap this up, that's all we really need for random floating point numbers. We can save this with Ctrl S, but we still have two more steps to go. One is for shuffling the arrays, and one is for picking from a random array. Doesn't really matter which one we start with. Let's start with shuffle. So press Ctrl+Shift+F, search for shuffle. We can use the parentheses as well if we want to. And if we take a look at this one, we have a couple matches, right? So the first one is inside cardpile.gd. So if we click on card pile, we have a shuffle method, and card piles have an export variable, which is an array of cards. So what we do is we call the shuffle method on that array. And that no longer does it because this shuffle method uses the global scope random generator. So it's not seed-based. Instead, what we want is call our own RNG.array shuffle method and pass the cards array as a parameter. We can save this with Control S, go back to the search results, and let's go to player handler next. So in here we have two lines of code. Both of those are the same. When we start a battle, we call the characters draw piles shuffle method. So you could say that, okay, so we need to put this inside that array shuffle method as well, right? Well, not really, because the draw pile of the character stats is a card pile resource. So if we press and hold Control, it won't open up the documentation. It will open up just the method we changed, right? So we already do the RNG based one here, the seed based one. So for those ones, we don't really need to. It would result in an error message, right? Because the draw pile is not an array. And our RNG.array shuffle method takes an array as a parameter. But this is not an array, this is a card pile resource, okay? And it has a shuffle method which already uses our RNG seed-based random number generation because we just changed it. And we had a line of code at line 88, and it's the same. We shuffle the draw pile, so we don't really need to change anything related to this. So let's go back to search results. And we do have two calls inside our shop.gd. When we generate shop cards, we shuffle the available cards array. And this is an array, right? So we do have to use the RNG-based version of this. So instead of this line of code, we do RNG.array shuffle available cards. This will make it consistent. And if we scroll a bit down, the other search result we have is this one, the same for relics. So instead of available relics.shuffle, we'll call RNG.array shuffle available relics. Yes, those were the two matches. And we have one last one inside card pile view, because if you remember, when we update the card pile view, it can happen that the view should be randomized. Why? Because in Slay the Spire, your draw pile is shown in a random order, so you can't anticipate which cards you will draw in your next turns. Instead of this line of code here, we'll just say RNG.array shuffle or cards. Awesome. So we can save this with Control S. And really the last thing we need to look out for is picking a random item from an array. So all arrays have a method called pick random. So we can search for pick underscore random with parentheses by pressing Ctrl+Shift+F, click on find. And we have two instances of these, one in the battle reward and one in treasure.gd. So let's click on this one first. So in this place, when we get a random available card, we pick a random from the array. Again, the problem with that is that it uses the global scope random generation, which will be different every time you run the project. So instead, what we can do is we can say RNG.array pick random, which is our own custom implementation, and pass that all possible cards array. And if we go back to the search results, we have a similar problem in treasure.gd when we generate the new relic. And again, we can just change this to RNG.array pick random available relics. And that's pretty much it. So if we save this with Control S, we looked at all the different random generations that happen inside the whole project, and we replaced it everywhere where we needed to. So let's test this, right? Because we did a lot of work. So if we create a new run, it's perfect. We have a battle and then we have a shop. So let's go into the battle. Okay, let's test a couple of things. So the crab, it was a crab enemy and he decided to block for 6. And as I drew my cards, I have a defense, 2 attacks, 1, 2, 3, and my power card here, right? Inside my draw pile, that's the order I see. I have the blue card at the beginning and then attack card at the end. So if I press escape, go back to the main menu, click on continue. Did you see that? The whole thing is perfectly put together again. So the crab enemy blocks for 6. I have a defense card, 1, 2, 3. If I click on my card pile, I can see the same order here. So this works pretty much how I want it to be. The whole thing is very predictable. And on my second turn, I draw my strike, defend. So if I go back to the main menu again, play out the same turn, the crab enemy will do the same thing. I get strike, defend. So I can attack him, take 7 damage, take 2 damage. I can just kill the enemy. I get 56 gold. I can add a new card to my deck. And if before going back to the map, I reload the same fight again, I should be able to get the same rewards, same amount of gold and everything. So let's play out that fight again. I draw the same cards. I can finish the enemy. I get 56 gold, and I was offered with 3 AoE attacks. I can skip them. Let's go into the shop. These are the cards and relics which are offered to me. These are the prices. If I press escape, go back to the main menu and re-enter the shop, I have the same relics, the same cards, the same prices, right? So pretty much everything works fine. If you want to, you can test the whole game. We can go throughout the whole treasure room. Let's do that. Okay, so arrived at the treasure room. I can click on the treasure. I get this reinforced armor. So if I go back to the main menu, press continue, I'm again at the treasure room. And again, get the reinforced armor. Awesome. So everything works pretty much as it's supposed to. We have our RNG system ready to go. And this pretty much wraps up the whole project. I hope you enjoyed season 2. We still have one more video to go where I address some of the bugs and issues you mentioned in the comments and some I discovered myself. So we'll have an extra video dedicated to bug fixing, but in terms of functionality, everything we prepared for season 2 is done. So I guess I'll see you in the last one. Bye bye.